Okay, this is going to be a demonstration and walkthrough of a photograph or image mapping utility. This was part of a master's capstone project that I performed for the Information Systems Management Master's program at Ferris. What I'm going to do is I'm going to get right into the actual outline of what we're going to cover. So when we say photo or image mapping, what are we talking about? We're going to cover that. Then we're going to go through digital forensics investigation issues. We're going to tie that into photo mapping and why these things can go together. And then we're going to talk about EXIF standards, what are these and how do they apply to images. And then we're going to talk about the visual analysis process with GPS. And then we'll move into the actual utility information. We're going to talk really briefly about GPS accuracy, which is very important. And then we're going to wrap up with a demonstration. So I'm going to continue on. Here's the sources for an image that we're going to see coming up. The other sources for this project and what you're going to see is actually in a paper that I've written. If you'd like to see that, you should contact me directly, as well as if you would like to try out the utility, you should do that as well. Now, image or photo mapping is really the concept of taking a photograph and then utilizing things like its GPS longitude and latitude, which on the screen here and in the screencast we can see that measurement here, and then we can see where on the globe this particular photo was tagged as taken. And we're going to talk about there are different programs. We're going to talk about how the GPS, where the GPS comes from for the photo during the EXIF portion. But when we talk about mapping like this, there are many different applications that allow you to do that. Google Earth is one. There is iPhoto is another. Obviously, I'm working on a Mac, so I'm familiar with that. And some of the large consumer tools will let you import, large groupings of photos together, like from a vacation, and you can mark them as an event. But what we're talking about here, and what this tool does, is something different. It does do that at a certain level, but it also does additional things for a forensic examiner, and we're going to talk about that. But from a digital forensics investigation perspective, forensic examiners, they're really faced with, quite a few different challenges. One of them is time. And with time, they have to use scientific method to review the evidence that they have and prepare it for court testimony, in essence. So in doing that, they're usually faced with multiple evidence sources. You could have smartphones, you could have tablets, you could have desktop, laptop. I mean, there's a whole myriad of platforms that could be involved. There's also, for each of these platforms, there can be a tool. Many forensic examiners use multiple tools because different tools do different things better. This obviously convolutes and complicates the process of doing one static examination, especially if you're garnering images from multiple sources. In addition, there's just massive quantities of evidence. In today's investigations, you can literally be staring at hundreds or thousands of files, if not millions. And you have to go through those and try to answer the questions for the investigation that you've been charged with. So, it's a lot of work. And what we're talking about here is a tool that's going to try to help reduce the time in order to review things like a photo or a digital image and its capture. In particular, we're going to talk about smartphone captures and the data that is hidden, if you will, within the actual image itself. And we're talking about using that. And specifically, this applies to any captures that are found on any particular platform. But we're going to say, in particular, even if you only have this images from a smartphone or a couple of smartphones, you could use this tool to garner information for an investigation, and we'll show you how. So before we do that, though, we need to talk about EXIF. What is EXIF? EXIF is, in essence, a metadata standard that was created, in essence, back in the 80s. It's been added to with new equipment as it's been created. There are different components to EXIF. In particular, we're going to talk about the digital image portion of that. There's also video and audio standards. We're not going to talk about those. This is focused solely on image capture. So when we look at the example of what we have here in the hex editor, you can see that there's information over here. We're going to and with these are, if you will, tags. So there are chunks or information that is outside of the actual image itself. So within an image, within an image file, I should say, there is actually the actual image itself, which I will call the payload, and then there's a header and there's a footer. And within the header and footer information, different devices can embed information about the image. So we're talking about metadata, or the catchphrase is data about data is how they define metadata. Let's take a look at how that works. So in essence, this is some raw, for the most part, metadata. So here's the different tags. It's in different formats. There's a large chunk here of data. That's actually the thumbnail. And if we scroll all the way down, we've got more information as far as for these EXIF information. Obviously, some of it can be difficult to read. We're going to take a look at an actual hex viewer and editor. We've got things like it's saying it uses the EXIF standard. It's giving me information about the capture device. It's giving me information about original date and time, but I don't really know that by straight looking at this. Some of this information is not necessarily human readable, which makes it a little difficult. So there's tools like EXIF tool, which was written by Phil Harvey, excellent tool, allows you to read and write information into the tags or the metadata. So it lets you see the EXIF information. I've highlighted a little bit here. So here's those dates, and it's giving you the tag definition. So it's saying that this tag, date, time, and original, has this value. So it's hidden. It's not necessarily available right within the OS, and we're going to actually talk about that. So we really need tools to be able to view this EXIF data effectively. Now, when we start talking about GPS and examining an image, such as this one, in an investigation, we can review only so much with forensic tools. It may give you numbers. So like, for instance, we've got created date and time. Obviously, this is wrong. That is not the correct date and time, but that's what came over with it when it was brought into the OS. And when you start looking at GPS tags like longitude and latitude, I'm not sure about you, but me, I do not know where -86 and +41 for longitude and latitude fall on the face of the Earth. I just don't know that. Those obviously numbers have numeric values to me, but I cannot tell you by just looking at this information where that point is. So I really don't know where this photograph was tagged as being taken. And of course, as a forensic examiner in a standard forensic tool, I may not necessarily have that opportunity. Now, if I look at a collection of images such as these, how do they relate to each other? Both spatially, so where were they taken, and then temporally, so, or from a chronological perspective. So when were they taken? In what order? That's the type of questions I might have as an investigator or a law enforcement official when I'm reviewing images like this. So what this is this is a screening shot of the output from the tool, which we'll actually demonstrate. But what we've got here is we've got GPS information in this little pop-up. All of these tags were part of the output of this tool, identifying tags that are probably going to be a good starting point for forensic examiners. It'll give you make, model. It'll tell you the date and time of the original capture. If there was a software loaded on the phone and it reported on it, what was that software? And then in particular, what was the EXIF version? There are different versions of this EXIF standards. And so you have to, if you have to look up tags and understand exactly what they mean, you need to look that up by the EXIF version. We're going to talk more about how these relate to each other in the demonstration, but really quickly, what you're seeing here is you're seeing a camera icon for each image that you saw previously. And in addition to showing you the spatial reference, so for example, that this particular photograph was taken here in Indiana, it's also telling you the order that they were taken in based off the red line. The red line indicates chronological order of the actual image captures. It's not path that the device traveled. It just shows you what was the order that they were taken in, which in an investigation can be very, very important. The other thing is when I look at this, I can garner a sense of spatial and temporal references very quickly based off of looking at the output from the tool. And we'll talk about what other benefits utilizing Google Earth in particular can provide for a forensic examiner. So this particular project had some goals. These were to mark a location on the map if it has GPS. It has to also deal with only images in the directory, or not only images, other files in the directory. So it has to know the difference between an image file and a non-image file. If it has GPS, if it does not, it has to map those accurately. That was all part of the testing and control groups that were checked. We have to maintain file hash. So what does that mean? That means that we cannot alter the file in any way. That's pretty critical when you're doing digital forensics work. You should not be altering your evidence. Also, this needs to be able to easily handle groups of images. You know, for example, we'll bounce back to iPhoto. iPhoto, you can hand it just a whole directory of photos and it'll map that. But as it does not necessarily do the temporal reference, and it does not provide all the individual tags that you saw earlier and that we'll show in the demonstration. So, and of course, the EXIF tag list, which we've talked about a couple times. Part of this project also included, do the vendors really use the tags correctly? Some of them do not, and that's actually in the paper. We're not going to get into that too much here in this presentation. Before we go into the demonstration, I'd really like to cover some GPS accuracy issues that, especially as a forensic examiner, you need to be aware of. Different cell phones have different GPS tagging capabilities. So for instance, this particular phone in the image capture that you see on the screen here, there is a point and it shows that it's out in the middle of a lake. Since I took this image myself, I can tell you that this was not taken out in the middle of the lake. It was actually taken right here where the yellow push pin is at. So there's a pretty good distance here between the two. And how did this happen? This happened in particular because the phone that I took this with does not have true GPS. So in other words, it's using cell towers to determine the GPS location. This is not as accurate as a true GPS reading. So it can take time. You can see your actual positioning move, especially in certain applications, as it becomes more accurate. So quick snapping a picture can actually tag it incorrectly. Now, the other thing that we need to keep in mind is that even if you have true GPS capabilities on a cell phone, if you're in a structure that impedes the ability for that to operate, it will then bounce, excuse me, it will then bounce over to the cell tower method. So that means that if you're in a particular court case review and you need to be able to confidently say down to less than 100 feet where something was at or where a picture was taken, you need to understand the limitations of the technologies. You also need to understand the environment that it was taken in. There's a lot of factors that can impede that, and you're going to have to get into a detailed review in order to even be able to come close to doing that. So very important to understand GPS accuracy and its limitations. So what we're going to do now is we're going to get into the demonstration. Before we show you the actual Python version, what we're going to do here, if I can get this to come over, is we're going to do this in Windows. There's actually a Windows executable version, which is in this folder that I'm showing you now. What I'm going to do is I have images as well as some other files that are in this folder. I can't really see a lot about these images right now. I may not necessarily have all the tag information that I'm going to show you displayed in a forensic suite. Some of them support EXIF better than others. But what I want to know is how do these relate to each other spatially and temporally. So I've dropped that folder into the actual location, which is here, and I'm going to run, actually I'm going to drop that in there, and I just did that. I'm going to run this executable from a command line. I type that in, I start to type in my folder, I'm using tab completion, and I press enter. In that time frame, it examined all the files, it determined which ones were images, and then it turned around and told you which ones did not have any GPS coordinates, and then it mapped them for you into a KML file. Why a KML file? KML file, which is here, is created because that's the primary import method for Google Earth, which is what we're going to use here. The other piece that you need to be aware of is that it builds the file name based off year, month, day. Okay? And actually, there's an updated version here, which I'll show you in the Python version over in Mac, that will also include the hour and minutes. All right? And since we have this output, they work the same. Obviously, there's a version difference here, but what I'm going to do is I'm going to show you the native Python version, which is here, and basically same. Instead of just typing the EXIF, I have to type in Python to call out to the system. I'm using Python, my script name, and then my folder that I've nested images in. And it will then run. You see that here we have the example with the hour and minute. And so now what I can do is I can go out and look for that. It's here. Make sure my naming's correct. It is. We're going to open this. We're going to go straight into Google Earth. We're going to see this. We're going to see this tool in action. Obviously, the majority of the features here are within Google Earth. The KML piece that you witnessed there is the examination and prep for import into Google Earth. So there's quite a few different things that happen within that. We're not going to get into the big details of that. And as this the res comes down to a nice, or goes to a nice level here, we're going to show you a few things. So in here we have information. Obviously, you're not going to come back to a command line to figure out which ones were not mapped. So in order to deal with that, we have that in the Get Info or Properties section, and that will tell you which ones were not mapped from the directory. We also have each individual image. This utility was based off of an initial utility built by Google, and it was added to considerably in order to do this. So there are, you have the ability to fly into an image, and what we're going to do is we're going to fly into an image right now. So what I can do is I want to see what this image is. You know, show me what that image actually is, and then bam, here's the image. And now, so this actually, instead of using a thumbnail, uses the actual image itself. Basically uses href tags to do that. You know, part of my opinion is that it's nice because now I can actually look in the photo. The res on this is a little blurry, but that has to do with the capture. I can then exit this photo, and then I can zoom back out, and this gives me information on, you know, reference. Where was this taken? So now I can see a lot of information depending upon how much I zoom in and I zoom out. So again, I can say show me other detailed information about this, and here it is. Here's my basic tags that I'm going to need to start reviewing these from a forensic perspective. It also gives me date and time, as I mentioned, software, etc. One of the nice things is it gives me a chronological order of the captures. And the interesting thing for forensic exams is, let's say, for instance, as I'm doing this, I have other information, let's say witness testimony, that says there was an exchange of something. And we'll say it's exchange number 3 or 2. And I'm going to go ahead, and what I'm going to do is I'm going to leave that marker, but I'm going to turn around and say I want the label to be red. Oops, if I select the right one, and then boom. So now what I've done is I've added in additional information from my investigation, and I can save this and I can continue to build it as the investigation goes on. I can add other tidbits from other suites or other data sources that may not necessarily be images, and then as an investigator I can start to build a visual reference and do a visual analysis of the information that I have concerning this case. Now I'm going to quit Google Earth. I'm not going to save. We may have to redo some stuff when we get back in there. But what I want to demonstrate now is I want to demonstrate the ability for this utility to take multiple inputs from directories. So we're going to do that now. It's going to run, and it's done. And we're going to turn around, and here that is. We're going to go back to Google Earth. And now we're going to see that this can actually help with some pretty good, obviously, regional or national or global investigations with Google Earth. And the other thing is we're using Google Earth because we don't want evidence for a court case to be out on the web. So this is a localized version. That's why this is built the way that it is. It's to help preserve evidence and not make it openly available, which it should not be. At least not during the investigation stage until it's released later. So we can see here we added some photographs that took place in Florida, and in particular the really interesting thing, and you can get into this with visual analysis as I zoom in, you can see the zigzags. Obviously there was a lot of movement back and forth. That's displayed here. So that's some of the things that you can get into, and of course those images, they're all blended here. It tells you the name, the folder that it's in. So there's a lot of information here that can be garnered and utilized in a forensic exam. We're going to go back, we're going to wrap up with, obviously we talked about GPS accuracy. There's differences between civilian and military GPS. Obviously, military GPS is much more accurate for particular reasons. So you need to understand what technology, data source, or, which GPS technology was used on the data source that you're examining. We talked about some tag usage, and we talked about the visual analysis that, we don't, as a human, we don't know what a GPS coordinate means until we see that visually on a map. So that was part of the reason for this particular tool to be created. And that pretty much wraps up the presentation. Obviously, if you have any questions or any commentary, we would love to hear it. Thanks.